Okay, welcome to Linear Graphs, flip lesson number 3. So last class we graphed equations that were in point-slope form. We would look at these equations and we would realize we want to get rid of the parentheses by distributing the -2. So -2 times x is -2x. -2 times 5 is -10. We'd bring down everything else on the left side and we're like, we're almost there. We're going to get our y by ourselves by getting rid of the 4. If we add a 4 to get rid of the -4 to one side, we have to do the other. And then we would add the like terms together. -10 plus 4 is -6. And then we're like, yay, it's in slope-intercept form. And we graphed it. We're getting really good at graphing things when they're in slope-intercept form. So we'd find the -6 for the y-intercept. 1, 2, 3, 4, 5, 6. And then our slope is -2, which means down 2 over 1. Okay, we have a choice here. See how I'm going to fall off the graph right here, and so will you. There's really not a space. I could make a space and go down 2 over 1, or if I wanted to, I could reverse. See how we went down 2 and then to the right 1? If I reverse my pattern and went up 2 and to the left 1, it still gives me a point that's on the line. So sometimes when you find yourself running out of space, you can go ahead and reverse yourself and you'll still end up, boy, that should be a straight line, Miss Overby. That is a really curved line. Should be nice and straight, right? Okay, hopefully you're having better luck with that than I am. All right, so that's what we did last class. But today we're going to look at a new form of a linear equation. So this is linear, but this is in what we call standard form, where the x and the y's are on the same side, and the number without the x or the y is by itself on the other side. When you see an equation in this form, you know that that's called standard form. And so there are two methods that we use to graph a linear equation that's in standard form. The first is what we did with our slope, our point slope form, which is change it into slope intercept. Or there's a second method that's called the cover-up method. I'm going to show you both, and you can pick which one you want to use. So the first one is looking at 3x plus 2y equals 12 and saying, we want the y by itself. To get the y by itself, we need to get rid of this 3x. To get rid of the 3x, we're going to just get rid of it and subtract it, right? Which is great. It's gone from this side. I'm going to bring my 2y down. Once again, whatever in an equation, we've got to keep it equal. Whatever I do to one side, I have to do the other. Now watch. This looks weird. 12 minus 3x. Don't write 9x. Please don't write 9x. Now, I agree that 12 minus 3 is 9. But you know what 12 minus 3x is? Wait for it. 12 minus 3x. They're not alike. We cannot combine things that are not like terms. So we're going to go ahead and write 12 minus 3x as 12 minus 3x. Then we're going to look at the 2 in front of the y. We want to get rid of that. Well, what's going on between the 2 and the y? Do you see anything in between the 2 and the y? I don't either. They're right next to each other. And when a number and a variable are right next to each other without a plus or a minus in between them, that means they're being multiplied together. 2y is the same thing as saying 2 times y. So to undo that, to get rid of the 2, we're going to go ahead and divide. And this is how we're going to do it. We're going to put a fraction line and with a 2 under it. Here's the deal. 2 divided by 2 is 1. That gets rid of your 2, and you just have a y, right? If I put 2 divided by 2 in the calculator, it's going to give me 1. I could write 1y, but when I just write y by itself, that's what it implies, that there's just one y. But wait a minute, you're right. I can't go dividing one side by 2 without dividing the other side. So here's what I'm going to do. On the other side, there are two terms. There's a 12 and there's a minus 3x or a negative 3x. I have to divide both those terms by 2. So I'm going to divide the 12 by 2 and the negative 3x by 2. So then I say, this is great, 12 divided by 2. If I put that in my calculator or do it in my head, I get a 6. But here's where it gets a little tricky right here. We're going to want to naturally try to reduce that, but we don't need to. We're just going to bring it down and rewrite it. We're going to make it look a little different, get the x out of the fraction line. So then we're like, oh, I see what's going on, right? We're almost there. We're almost in y equals mx plus b form. Can you see that all we have to do is flip these two things around and we're there? Now, some people can graph looking like this. Some people can go, Miss Overby, I don't need to flip them. I already see that that's the y-intercept and this is the slope. And that's great. If you can see that, don't flip them. But for the rest of us, I'm going to flip them. So here we go. Oh, I guess we can keep the flipping part. So what we're going to do is this. We're going to realize this part is the slope and the x. So we're going to put that first. This part is a 6. Is it a positive 6 or a negative 6? It's positive, so we're going to put a plus to separate it, okay? What I just did is the same thing as if I had 4 minus 2. If we put 4 minus 2 in the calculator, we're going to get 2, right? But I could switch it around and write it as negative 2 plus 4, and it's the same thing. If I put that in the calculator, I am going to get a 2, okay? Now, some people are going to look at this method and be like, I can't wait to see the next one. And I don't blame you. Some people are going to look at it and go, oh, that's not too bad. I could do that. So let's go ahead and finish this up. Y-intercept is 6. 1, 2, 3, 4, 5, 6. And we're going down 3. 1, 2, 3. Over 2. And there we've got it. All right, we're going to take the same problem and we're going to use the second method. Are you ready? Let's see how, okay, 7 minutes in, let's see the second method. All right, this method has a little cute name. It's called the cover-up method. And this is what the cover-up method is based on. It's based on finding the x-intercept and the y-intercept that a line has. Like for instance, let's say I were to take a line. Let's find one that's straight this time. Let's do a line and let's make it the color green. All right. Okay, there's my line. So let's say I make a line that's, how about it's like, uh-oh, I'm trying to get an even x and y intercept. Not so easy, right? All right, let's try to move this line a little bit so we get something. And bear with me, we'll get there. Okay, so now we have a line that has an x and a y-intercept. Now, once again, what I'm doing right now has nothing to do with this problem. So hopefully you are listening to me. Otherwise, if you're just watching it, this isn't going to make any sense. So here we go. This is the y-intercept, right? And this y-intercept, if we were to name the point, it's 1, 2, 3, 4, 5, 6. A lot of times we'll just say 6 is the y-intercept. But if we were going to formally name the point, it's 0, 6, right? And this would be 1, 2, 3, 4. This would be the x-intercept. We would informally say -4 is our x-intercept. But if we were going to formally name the point, it would be -4, 0. Okay? Now, because lines have x-intercepts and y-intercepts, we can use the cover-up method to kind of shorten the work that we had to do in the same problem but the slide before. So here's how it's going to work. I'm going to get rid of this. Hopefully you were, oops, and I got to get rid of this too, don't I? Let's see, let's get rid of it. Let's delete that, and let's delete this while we're at it. Okay, so here we go. When we're looking for the y-intercept, we know x is going to be equal 0. So what we're going to do is this. We're going to take 0, plug it in, and what happens when we plug in 0 for x? 3 times 0 is 0. It goes away. So we're going to use this orange thing, and we're going to cover this up. Hence the name cover-up method, right? Because once something's equal to 0, it's gone. We're going to cover it up. And look what we have. We have 2y equals 12. Now you can do it in your head. You can say 2 times what equals 12? Oh, 6, right? And you would be right. Or you could do it formally. You could say Either way is good. Okay, so we just found the y-intercept. That's going to be 0, 6. If we plot the point 0, 6, that 0 means don't go left to right, and 6 means goes up. 1, 2, go up. 1, 2, 3, 4, 5, 6. There we go. We're halfway done. Now we need to find the x-intercept. And that means for the x-intercept, all the x-intercepts have y equal 0, right? If you think of any point on this x-axis, all y's are equal to 0 on the x-axis. So we're going to plug in a 0 when we see y, and 2 times 0 is 0. It went away. Let's cover it up. All right, if it's gone, then we're just left with 3x equals 12. You can do it in your head. 3 times what equals 12? 3 times 4 equals 12. Or you can work it out, right? 3x equals 12. Divide both sides by 3. X equals 4. And we're going to go plot this point, 4, 0. 1, 2, 3, 4. And there it is. All right, so I'm going to try again. I can do better than that, can't I? Let's see. Better a little bit. All right, so that's our second method. It's the cover-up. I'm going to encourage you to try to stick with the cover-up method because once you get the hang of it, it's actually pretty efficient and less work than the work that we did back here. Once again, this is a very valid way to solve or to graph a linear equation in standard form, and so is the cover-up. Let's try the cover-up method again, but this time I want you to note we're going to be really careful with the minus. See how we have a minus sign here? When we do the cover-up, we have to be thinking about that minus sign to make sure that nothing happens with it. All right, so let's see. We're still going to do the same thing, right? We're going to plug a 0 in for x. When we plug that 0 in for x, 9 times 0 is 0. Cover that up. It's gone. It's equal to 0. Now watch. I'm not going to cover up that minus. If I cover it up, then I'm going to get the wrong answer. I got to pull it back and let that minus show. Now, this one's going to be a little harder to do in your head, but you can challenge yourself. This says negative 6 times what equals 18? Negative 3. I'm with you, right? It's negative 3. Now, a lot of you like to be very careful with your calculations, and you like to double check yourself on the calculator, or you just like to go straight to the calculator, and that is very fine. So we're going to go ahead and write negative 6 equals 18. We divide both sides by negative 6. We would pick up our calculator, put 18 divided by negative 6, hit enter, and it's going to give us a negative 3. All right, either way is good. All right, so now we're going to go. This is my y-intercept. I'm going to plot it. 0, negative 3. I'm right. 1, 2, 3, right there. Woo, halfway done. All right, let's take that cover up and move it. Now I'm going to find the x-intercept. So that means I'm going to take 0. Let's change my color. I'm going to take 0 and plug it in for y. And if I do that, negative 6 times 0 is 0. It's gone. And all I have left is 9x equals 18. 9 times what gives me 18? 9 times 2. Formal way would be like this. We're going to go graph that over 2. And we're going to do a really good job. And we're going to connect our dots. Whew, I'm getting better. Hopefully you're using a ruler. All right, so I believe that's it. What I want you to do before you put your notes away is really look at what we just did. We are going to get a lot of practice in when I see you in class, but review the methods and decide, are you going to challenge yourself to do the cover-up method, or you can stay with the tried and true, changing it into y-intercept form. You can work on both of them when we get in class. Thank you very much for joining me, and I will see you in class.